And welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring how to write quadratic functions when we're given the focus and directrix part 2. Now, in our previous lesson, we looked at parabolas which opened either up or down. In today's lesson, we will be looking at parabolas that open to the left or to the right. So parabolas that open to the left or right are said to have a horizontal axis of symmetry. They'll open to the right if p is greater than 0, and if p is less than 0 or negative, the parabola will open to the left. Now, in order for parabolas to open to the left or to the right, the value of y must be squared. Now, we'll talk about that more in a minute, but first let's label some images here. So in our first image, we have a parabola that's opening to the right. So what we know here is that the value of p must be positive or greater than 0. Okay. Now right here is our vertex, and then it opens up towards the focus. That would be the focus. And then we also have our directrix, which is a vertical line with the equation x equals h. All right. Now, our second parabola opens to the left. So parabolas open to the left whenever the value of p is negative. And so here we have our vertex. That means if we go to the right, we would have our directrix. And if we go to the left, we would have our focus. So very similar to our previous lesson. Now, the equation of a parabola with a horizontal axis of symmetry is y minus k quantity squared is equal to 4p times the quantity x minus h. Now, what I want you to notice here is, excuse me, the h goes with the x and the k goes with the y. So you always want to keep your h value with your x and your k value with your y. Now, this will make more sense when you look at a couple of examples. So in example 1, it says, given the directrix x equals 2 and focus 8, 0, create a sketch, find the vertex, and write an equation to describe the parabola. So our directrix is the vertical line x equals 2. So here on our x-axis, we have a point at x equals 2, and we'll draw our vertical line. And remember, this is called our directrix. Okay. Our focus point in this problem is at 8, 0. So 1, 2, 3, 4, 5, 6, 7, 8. So our focus point, and remember, so important to label, or you'll get the focus and vertex mixed up. So our focus point is at 8, 0. And the vertex is always halfway between the directrix and the focus. So the directrix and the focus are 1, 2, 3, 4, 5, 6 units apart. So that means my vertex is 3 units from the directrix. So 1, 2, 3. So I'm going to put a V right here for my vertex, and I'm going to record the coordinates. So 1, 2, 3, 4, 5, 0. Now remember, parabolas always open towards the focus. So this parabola is going to open to the right, which means p must be greater than 0 in this problem. So it must be positive. So from yesterday, to get the value of p, we just count how many units is it from the vertex to the focus. So 1, 2, so 3 units. So the value of p is 3 units. Okay. Now our focus point they gave you, so write that down. Our directrix they also gave you, x equals 2. The next thing we're going to do is get the width of this parabola. The width of a parabola is the absolute value of 4 times p. So in this problem, that would be the absolute value of 4 times 3, which is 12. So I'm going to go 6 units from the focus, up 6, 1, 2, 3, 4, 5, 6, and down 6, 1, 2, 3, 4, 5, 6. So there's the width of the parabola. Now you're going to take and make a U-shaped curve connecting the vertex and these two. Well, that's not a very good U-shaped graph, but that's the general idea. You've got a parabola that opens to the right. Now, to get your equation, because this parabola opens to the right, I want to use this general formula. Y minus k quantity squared equals 4p parenthesis x minus h. So in this problem, our h is 5, our k is 0. So y minus 0 squared equals 4 times p, which is 3, times x minus h, which in this problem is 5. Now, let's simplify that a little bit before we put it on the answer line. So y minus 0 is just the same thing as y. So y squared equals 4 times 3 would be 12, and then parenthesis x minus 5. All right, final answer. All right, let's look at another example. In example 2, it says, given that the focus is 0, 4. All right, let's plot that. 1, 2, 3, 4. All right, so they gave us the focus is at 0, 4. I'll go ahead and write it down over here. The directrix is x equals 4. So 1, 2, 3, 4. So that's a vertical line at x equals 4. Let me label that to abbreviate it. That's our directrix. And remember, oh, wait, let's write that down too. X equals 4. Okay. Remember, our vertex can be found halfway between the focus and the directrix. So it is how many units from the focus to the directrix? 1, 2, 3, 4 units. So that means the vertex must be 2 units away. So I'm going to put a V right there. And then to label that point, that would be 1, 2, 1, 2, 3, 4. So our vertex is 2, comma 4. And just by way of remembering, I'll put a HK above that. All right, now let's talk about which direction this parabola is going to open. It's always going to open towards your focus. So that means this parabola is opening to the left, which means the value of P must be less than 0 or negative. All right, so what's the distance from the vertex to the focus? So it would be P would be negative 2. All right, now to get the width of the parabola, it's the absolute value of 4 times P. So that would be the absolute value of 4 times negative 2, which would be the absolute value of negative 8, which is 8 units. So from the focus, I want to go up 4, 1, 2, 3, 4, and down 4, 1, 2, 3, 4. Now I'm going to connect those with a U shape. So there's my parabola that's opening to the left. Now, the last thing we're supposed to do is write the equation for this blue parabola. So I want to write down my general formula. My general formula for parabolas that open left or right is y minus k, parenthesis squared, equals 4 times p, parenthesis x, minus h. All right, so let's plug in everything we know. We know that k is 4, so y minus 4, parenthesis squared, equals 4 times p, which is negative 2, parenthesis x minus h, which is 2. All right, let's simplify that. That would be y minus 4, parenthesis squared, equals negative 8, parenthesis, x minus 2. All right, example 3. given that the focus is 0, 2, so let me plot that and be sure to label it. Whoops, 0, 2. And the vertex is -3, +2. So 1, 2, 3, 1, 2. There's the vertex. All right. Now, the parabola, oh, we can find the directrix too, because the directrix would be in the other direction. So 1, 2, 3. So 1, 2. Let's see, 1, 2, 3. So this is our directrix. It's a vertical line at x equals 1, 2, 3. Okay. Now, what is the value of p? Wait, I just made a mistake. Parabolas always open towards their focus. So I made the directrix go on the wrong side, which is it's a very common mistake. And if you get going too fast, that's what happens, and that's exactly what I did. Let's get rid of that. I should have gone 1, 2, 3. Let's see, 1, 2, 3 in the other direction. So thankfully I caught it before we had finished the problem. I need to erase that. All right, so my directrix should have been x equals, let's see, 1, 2, 3, 4, 5, -6. All right, so there's my directrix. Now, let's see. This parabola is going to open to the right because it opens towards the focus point. So the value of p must be positive. So the value of p, how many units is it from the vertex to the focus? 1, 2, 3 units. So the value of p is 3. Okay. Now the width of the parabola is the absolute value of 4p. So in this problem, that would be 4 times 3, which is 12. So I'm going to go 6 units up. 1, 2, 3, 4, 5, 6. 6 units down. 1, 2, 3, 4, 5, 6. And then I can connect my parabola using a U shape. So I've got a really wide parabola here that opens to the right. Now, when parabolas open to the right or the left, the formula we use is parenthesis y minus k, parenthesis squared, equals 4 times p, parenthesis x minus h. So in this problem, we have y minus k, which is 2, equals 4 times p, which is 3, parenthesis x minus h, which is -3. All right, so when we simplify this, we would have y minus 2 quantity squared equals 12, parenthesis x plus 3. Okay, so there's our equation. All right, example 4. Given the directrix is x equals 0. So here is our directrix, x equals 0. And the focus is -4, -4. So 1, 2, 3, 4, 1, 2, 3, 4. And remember, you need to label that. -4, -4, directrix is x equals 0. Now, we're going to get our vertex. The vertex will be halfway between the focus and the directrix, which would be right here. And that is the point -2, -4. Now, because your parabola opens towards the focus, this parabola will open to the left, which means p will be negative. So it would be -2 units. Okay. Now, to get our width, we want the absolute value of 4p, which would be the absolute value of 4 times -2, which would be the absolute value of -8, which would be 8. So I'll go 1, 2, 3, 4, and 1, 2, 3, 4 to get my width. Then once you have the width, you can sketch your parabola. All right. Now, because this parabola opens to the left, the formula I'm going to use is y minus k parentheses squared equals 4p times x minus h. So I'll plug in my given information. This would be y minus negative 4 parentheses squared equals 4 times p, which is negative 2, parenthesis x minus h, which is negative 2. Now simplify that a little bit. Y plus 4 parentheses squared equals negative 8 parenthesis x plus 2. So there's the equation for the blue parabola that opens to the left. Now, in example 5, I'm going to go a little backwards here. I'm going to give you an equation this time, and you're going to find the given requested information. Before I do that, though, I want to write the general formula above this. It's y minus k squared equals 4p times x minus h. All right, so if I wanted to get the vertex, that's h comma k, the value of h would be in this parenthesis. So remember, we take the opposite, so that would be negative 3. The value of k would be in this parenthesis, so that would be positive 4. Okay. To get p, we know right now that 4p is equal to 12. So 1p must equal 3. Now, because the value of p is positive and the y is squared, I know this parabola is going to open to the right. All right. I also know the width of this parabola is 12 units. All right, now let's plot what we know. We know that we have a vertex at negative 3, positive 4. That is our vertex. We know the value of p is 3. So 1, 2, 3. This would be our focus. And then go the opposite direction. 1, 2, 3. Our directrix would be right here. So our focus, 1, 2, 3, 4, is at 0, 4. Our directrix is the vertical line. X equals 1, 2, 3, 4, 5, 6. X equals negative 6. Okay, now we need to sketch the width. So the width is 12. So 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. Now we can sketch our parabola. All right, example 6. A parabola has the equation y plus 2 quantity squared equals negative 8 parenthesis x minus 5. So above it, I'm going to write my general formula, y minus k squared equals 4p parenthesis x minus h. All right, so I know my vertex. I need h first. So my vertex is going to be 5, comma, the value of k would be negative 2, and we'll plot that. 1, 2, 3, 4, 5, 1, 2. Okay, and I want to label it, all right? The other thing we can do is get the value of p. So we know that if 4p is equal to negative 8, then 1p must equal negative 2. Now, because it's negative, I know my parabola is going to open left. So I want to go 2 units to the left. And that would give me my focus point. 1, 2, 3. Whoops, put it in the wrong place. Get rid of that. This was supposed to be -2. Now go the opposite direction, 1, 2 units, and that will give you the directrix. Okay. Now we know the width is the absolute value of -8, which at this problem would be 8. So 1, 2, 3, 4. 1, 2, 3, 4. Now connect those. And there's our parabola that's opening to the left. Oh, I forgot to write down the equation for the directrix. Excuse me. The directrix is a vertical line, so x equals 1, 2, 3, 4, 5, 6, 7. X equals +7. And that concludes today's lesson, graphing and writing equations for quadratic functions given the focus and the directrix.